Greetings, chemistry students. It's me, Mr. Cheney, with another brilliant tutorial. Actually, this is a summary of the Reactivity of Metals lab. This is a way for you to confirm that you got the answers you should have, or fill in the answers that you need. That way, everybody has the correct answers and everybody's able to turn in this assignment. So, the virtual lab, Reactivity of Metals, here we go. You get into the lab and you make sure you have your slide deck ready to go. And our scenario, once again, is making jewelry is about unique and beautiful designs. It's also about choosing materials. Many pieces of jewelry are based on metals. The clasp on a necklace, the main structure of a ring, or the hook on an earring. For a piece of jewelry to remain beautiful and functional over time, the metal chosen must be able to resist the wear and tear from chemicals of everyday life. For example, even making a salad could put a ring in contact with a dilute acid in salad dressing. Test the reactivity of several unknown metals in order to determine which metal makes the best choice for a ring. So we go to the investigate part, and once we're here, we want to read about each one of these elements because it's going to help us answer and actually make guesses on this stuff right here. So we go back, we read about the acid. It says all metals except the least reactive metals will react with dilute acid. Hydrochloric acid in a dilute aqueous solution is often used to test the reaction of metal with acids. If the metal does not react with the acid, then you know it is not at all reactive. Then we go to cold water. Metals are considered extremely reactive if they react with air or cold water. When metal reacts with cold water, then you know it is very reactive. For example, sodium is very reactive and explodes when in contact with cold water, which is rare. Hot water. Metals that are highly or moderately reactive will react with hot water or steam. If the metal does not react with hot water, then you know it is not very reactive. Okay, so now that we know a little bit about metals and acid versus cold water versus hot water, here is a chart of common metals, lithium being at the top, highly reactive, going all the way down to silver, which is nearly not reactive at all, and everything in between. So we'll read about our metal samples, and so the reactivity of 3 metal samples will be tested in this lab. Each metal will be identified by comparing the results to the activity series of metals. One sample is calcium, one is zinc, and one is silver. So by doing this experiment, we'll be able to figure out which is which based on the reactivity. Okay, so now that we know a little bit about the materials that we're working with and the fact that they're all metals and which ones should be reactive and which ones should not, now we have to go to our slide deck and make some hypothesis guesses, and then we'll conduct the actual experiment to get real answers. So we'll start that process now. Okay, so we need to make our guesses. We're going to go back, and so we've read about acid, we've read about cold water, we've read about hot water. We don't know which sample is which right now, so this is purely a guess. So which one's going to be most reactive, least reactive, and mid. So I'm just going to toss out some guesses because that's all they are. So I'll put most reactive, least mid reactive. And then I want to do that for cold water and hot water, so I'll just do that. I'll spread them out. So instead of typing them, I can copy and paste. So maybe I'll, for hot water, make this most, this, and least restrictive, this, so I've got my guesses in, so now we have to actually go and do the experiment. So we're going to start with acid, and when I was doing this in class, we did sample 1 with acid, and we saw that it did large reaction, big bubbles. So let's recreate that just to make sure. So acid, sample A, pour it in, you press play, and we definitely have a large reaction right here. So we're going to get our snipping tool to actually get that reaction. For our slide, so we'll copy that, go back to our slides, and sample 1. large reaction in bubbles. This slide right here, we're putting, if I wanted to paste that again, put it there. So now we'll do that same thing for sample 2. Do this, set sample 2 with acid, sample B I should say, and press play, and the water fills, and that is 0 reaction, no bubbles at all, nothing's happening. So you want to make sure you get your screenshot. Here, sample 2, no reaction, 0 bubbles. Here, I'm going to paste, show that 0 reaction, like so. And then we do acid for sample number 3. So going back to the lab, we will reset acid for sample 3. That has a really large reaction as well. It actually makes the sample disappear. That screenshot. That first slide, so that is going to be a large reaction. I would say that was more than the sample. Okay, and then we would go through and we're going to do cold water and hot water the same way. We do screenshots for hot water and cold water, and then we get to here where we're going to actually fill in, instead of guesses, we're going to fill in which is actually the case for each one. So for example, we know that acid for sample C was large reaction mini bubbles more than sample 1, so I can even just copy and paste it right here. So acid, C, right there. So you do that for each one. And the last thing you'll do is read through this and try to answer that as far as metal reactivity in the body, and that is your lab. So hopefully this helps. If you didn't get started, it will get you started. If you needed help finishing, this will help you finish. And I will be there live in class to help you get this finished as well. I will see you back in class.